Good morning, 7th grade. Welcome to week 6, day 1, April 27th. I just want to say that I think you guys did a really good job with proportional relationships. I think where you did struggle, a number of you reached out to me for feedback to better understand the misconceptions that you were having. Some of you even redid some of your work for a higher grade. So I'm happy to still see your eagerness to keep learning and really master understanding proportional relationships. We are scheduled to have an evidence of mastery on Wednesday, and we are taking an assessment on Thursday. So I do plan to post a quick review sheet on Wednesday to kind of give you an idea what to expect for the assessment on Thursday. Most of you guys have been doing very well on them, so I expect for you to continue to do so. Okay? So I'm going to click on your classwork. You'll notice there's a new agenda posted for week 6. You guys could check that out. And then we'll go to week 6, day 1. So I just have that clicked because I was already looking at it. So today we're going to be focusing on the 3 models, your table, your graph, and your equation of proportional relationships and then versus not proportional relationships. Really making sure that we all understand what makes something proportional and what does not. I also want to mention that on the stream, every day I've been posting since week 5 a takeaway, today's takeaway, and it really is just like a brief synopsis of what you really were supposed to get out of today's lesson. So make sure you check that out. I usually post it at 8:05 a.m. every morning, and it usually is a good help for anyone that maybe was a little unsure of the lesson. It's just like a quick snapshot of what you were supposed to get out of it, and usually helps you with the exit slip or the classwork assignment for that day. Okay, so I'm going to click on the lesson to walk you through it. The lesson is really modeled based on what your classwork assignment is today. So if you understand what we're doing in the lesson, then you should be able to do the classwork assignment without any problem. Okay, so we're going to focus on the different models of a proportional relationship and then look at it in a non-proportional relationship. So we're given a verbal description where it says Paul the bus driver. I made that based off my husband. Paul the bus driver picks up 35 passengers on each bus ride. Okay, so that's your verbal description. Then you're being asked to complete the table. Now, we were kind of nice in this one and filled in some of the blanks, but you should have been able to fill in this table solely based on that verbal description. So it's set up for us where we have the number of buses and passengers underneath. I do want to mention, I'm just going to get my marker ready, that the number of buses are determining how many passengers were on each bus. So we're going to make the number of buses X and our passengers the Y. Okay? So if Paul took 0 buses out, then how many passengers would have been there? There would have been 0. So right there, a little red flag should be going off in your head because we know in a proportional relationship, 0 must be included, and right there we made the connection that it would be included in this table. So right here I already have one of my check fors that this table may be proportional. The other one is to make sure that there is a constant, and we're going to check that out as we continue completing the table. Okay, so if I look at my table, I have 2 blanks and then a 3, and then I have 35 filled in, and then 3 more blanks. So it told us that Paul the bus driver picks up 35 passengers on each bus ride. So if this blank, which is empty here, but it's representing 35 passengers, well, we know for each ride, he's picking up 35 passengers. So this must have been 1 bus, because we know that for 1 bus, he's picking up 35 passengers. Then we have a blank to 3. So I think we could all assume that this blank would probably be 2. And if it's 2 buses, then we're going to increase this by plus 35, right? Because for each bus, he's picking up 35 passengers. So that would be 70. Okay, so let's see if we're noticing anything. So our top is increasing, I noticed, by +1. That happened here as well. And that also happened here. So I'm gonna just move ahead and put in this 4 here because I'm gonna guess that's probably what should be there. And then along the bottom, we went from 0 to 35, that's +35. And then we already said that from here to here would be +35. So if it's 3 buses, then of course it would also increase by +35 because again, for each bus, he's picking up 35 passengers. So that would now be 105. And if I make this last blank 4, then we know that we have to, again, increase this by +35, okay? So we would be left with 140. So looking at this table, a few things you should notice is there definitely was a constant, okay? And we do have that 0, 0, that is our look for. So I would say just based off this table, this is a proportional relationship, but we're gonna do the graph and the equation as well, okay? All of this is also in the lesson. I'm just breaking it down for you as you would see it, okay? So now that the table is completed, we can graph. And I labeled the characteristics of the table, X and Y, so you know which one goes where. So the X is always the bottom line, your horizontal line. This will be your X-axis, and we're gonna label it passengers. I'm sorry, number of buses. Right? Because that's what our X was. And then our Y is our line that goes up and down, and that's going to be our passengers. All right. So now the next thing you have to decide is what are you going to count each of these by? So let's go to the X. Our X's were increasing by +1 the whole time, so we might as well make our X-axis also count by 1s. So 1, 2, 3, 4. I'm including a little extra, but that's okay, just to fill up the line. We know that this corner is 0, so we can put that. That's our origin. And then passengers, our Y, our data was increasing by 35, so we should also count by 35. Since it's a constant number that's going with our table, we should make our graph match that. Okay, and I'll put one more just to squeeze that in there. Okay, so we have our graph all set up. We could give it a title if we wanted. Paul's work. Okay, and now we're going to graph our points. So our first point would be 0, 0. That's our origin right here. Next would be 1, 35, 135. Next would be 270, so I go to 2 along the bottom, 70 on the top. Then we go to 3, 105, so 3 along the bottom and 105 along the top. And then we have our last one, 4, 140. Okay, once you have your points plotted, you then take your pencil, pen, whatever you're using, connect your points. I usually put an arrow to show that it could continue. And now looking at our graph, we can also make a connection as far as whether or not we think it's proportional. So the 2 check-fors are, is it linear? Is this a straight line? Yeah, it's definitely a straight line. And does it go through the origin? It does. So our graph and our table, we have already decided our proportional relationships. The last thing we need to do is write the equation. So since we know it is a proportional relationship, that equation needs to be in this form. Y equals kx, because this is the proportional relationship equation. The k is the constant. To find that constant, we find that ratio of y over x. If we're looking in the table, we look for that change in y over the change in x. If we're looking in the graph, we also know this is our rise and our run in simplest form. Okay, so let's look at the table first. The change in y was 35, so that's going to be our numerator. So k is going to be 35, and the change in x was +1, so our denominator is going to be 1. Looking at my graph, we would see this as well, because if I pick two nice points here and here, my rise would have been from 0 to 35. That's plus 35. That's my rise. My run would have been plus 1. That's my run. That's my denominator. So again, it still would have been 35 over 1 if we look at it from the graph. Okay? So some of you are writing your equation like this. You have to make sure the equation starts with y equals, then your constant. I'm just going to write 35 because it's just easier. 35 over 1 is 35. And then after your constant should always follow with the variable x. Okay? So we have our verbal description about Paul. We have our table. We have our graph. We have our equation. And then the last thing that they're going to ask you is this proportional and why? So we should all know at this point, we've gone through multiple reasons why this relationship is proportional. You guys should know this by now. You can either say, because the table has a constant and includes 0. You can say, because the graph is linear and goes through the origin. Or you can include both. Okay, there's a model example here in purple. All right, so that's putting all three models together to describe a proportional relationship. Now, for today, your classwork assignment is going to be something very similar to this, where you're going to be completing 2 examples similar to this. So the next example I wrote on a piece of paper, and I did this to show you that if you don't have, I'm going to erase this because I feel like it's distracting in the background. If you don't have access to a printer or the capability to get the worksheet that is provided for your assignment today off the computer, you can do exactly what I did. All I did was I copied the problem that's at the top, which is your verbal. You pay $3 to get in a cab and $1 per mile driven. So all I did was I copied that right on to my piece of paper. Okay, the table. Now, the table on the lesson, they actually filled in more spots for you, but I wanted to see if you could figure this out. So for this one, they're saying you pay $3 to get in the cab. If you get in the cab, have you driven any miles? No. The answer would be no, right? So at 0 miles, you're paying $3 just to get in this cab. Then, after 1 mile, you're going to pay an additional $1 per mile driven. So you paid $3 to get in, and then it's going to be an additional $1 for every 1 mile driven. So this blank would then be 4, right? Because it's $3 to get in the cab. I drive 1 mile. I now have to pay $4. Okay? If it was 2 miles, well, guess what? We're going to pay another $1. I'd be at $5. Because for every 1 mile driven, my price goes up by $1. Okay? So I'm going to keep writing this so we can fill in the rest of our table. And here we have the same. Okay, so again, another mile driven, this would be 3. And our price would be 5 plus 1 is 6. And then finally, if it was 4 miles, 6 plus 1 would give us 7. So looking at this table, I'm already figuring out that this is not proportional. Why? Because that 0, 3 tells me that this table does not start with 0, 0. This table starts with 0, 3. So, oh no, this is not proportional. It might be linear because it does look like it has a constant. It might be a straight line, but it's not proportional because this is not 0, 0. Because this is 0, 3, this is not a proportional relationship. So now let's graph it. Let's see. So my miles would be my X. And my money would be my Y. So I'm going to do the same thing I did before. Label my X as miles. Label my Y as money. Okay? And now I'm just going to see my miles. They're going by ones. So I'll do the same thing. And again, like this is how you guys could complete your assignment too, and then just send me this. Send me this through our Google Classroom phone number, send it through text, through Instagram, through PupilPath, digitally through Google Classroom, whatever works for you, okay? Here we're increasing by 1. I don't start at 1, but I could count by 1 and see that 3 on my graph. So that's what I'm going to do. Remember, this would be our origin 0. I'm going to count by 1s so that I include all my numbers in my y. I couldn't start at 3 because then I'm not moving at a constant interval, okay? Because if you started at 3 and then went to 4, 5, 6, then from 0 to 3, it's not the same as 1 to 2 or 4 to 5, like that, okay? You have to make sure that this change as you go up is the same. So if it was from 0 to 3, it would have just been plus 3, and then you would have wrote 4 plus 1. Now your graph is all messed up and it would not work to model the data appropriately. Okay, so I'm going to graph now. So our first point would be 0, 3. So that's here, 0, 3. Okay, my next point, 1, 4. My next point, 2, 5. 3, 6. Now notice I'm not on graph paper, so you know it's not going to be the most accurate, but I get the idea. I'm now going to connect my points. Oops, hard to do with one hand. Put an arrow. And looking at this graph, I already know that this is not proportional because, yes, it is a straight line, but it does not go through the origin. So my graph is not representing a proportional relationship. It is representing a linear relationship because it is a straight line and there is a constant happening. So if it's linear, this is the equation that we worked on before we left school in March. This equation would look like this, where our constant is m and our intercept is where we start. So our constant you can either get from the table. Remember, m is always change in y over change in x. Or if we're looking at the graph, it would be rise over run. Okay, so our change in our y was plus 1. Our change in our x was plus 1. So our slope would be 1 over 1. Okay, or we could reduce that to just 1. And b, if you remember, it's wherever the x is equal to 0. So let's go to our table. When x equals 0, this number here will be your b. So b equals 3. Okay, and then we just plug these numbers in. 1 goes for m, 3 goes for b. So my equation would be y equals 1x plus 3. Some of you might remember we could also write it as y equals x plus 3, right? That 1's there even though we don't see it. It's hiding there. Okay, but notice that this is not proportional. It does not follow the equation y equals kx. Does not include 0, 0. Okay, and we could support that by looking at our graph as well, right? This right here is, oh my gosh, I can't do it with one hand, I'm sorry. This right here is not, can't do it, 0, 0. That point right there is 0, 3. So right there is your reason why this is not proportional. Okay, it is linear. I will say that it is a straight line, but it's not proportional because this is not at 0, 0. Okay, so today you are going to be completing 2 problems like these on your own. I'm just scrolling through so you can kind of see them. Oops. They look like this. I'm going to X out of it to show you the assignment itself. The assignment is right here. These are the different ways that you can send me your work for today. I'm going to click on it so you get a chance to look at see what it looks like. So you're going to be given a proportional example and a non-proportional example. You're going to be given a verbal. You're going to complete the table. Some of it has already been completed for you. You're going to make the graph. You're going to write the equation and tell me why this one is proportional and why this one is not proportional. So if you watch today's video, I walked you through 2 identical examples of one that was proportional and why, and one that is not proportional and why. Okay? So just rewind if you missed that, if you scrolled ahead. These 3 questions at the bottom, you're going to stop here, and these 3 questions are located in a Google form for your exit ticket today. So you'll click on, it's titled Recap, and when you go here, it's going to be the same 3 questions that you saw at the bottom of the worksheet. So you're not required to answer them on here. If you do, I won't take off credit, but you are responsible to submit this. These are the same exact questions from the worksheet, they're just multiple choice. Okay, I know this was a little bit long of a video today, but I wanted to make sure I really explained what you had to do today so that there were no questions. I hope that I helped, and everyone stay safe.